This is calculus 2. We're gonna do Lofter rules this session. Before we talk about improper integrals, we're gonna review indefinite forms and Lofter rules here. First thing is, what is the indeterminate forms? So let's talk about indeterminate form. Let's go back to calculus 1 class to find the limit. So we call indeterminate form is, looks like a 0 over 0 form, which meaning is, look at this limit right here. So limit x approach to 1, x squared minus 1 over x minus 1. When you see this limit, we're going to find this limit factoring over times conjugate. But before I introduce L'Hopital rules, when you do this one, guys, what are you going to do? You direct substitution. X approach to 1, you're going to try to think x squared minus 1, x minus 1, x approach 1, x squared minus 1 going to 0, x minus 1 going to 0. So when you see this limit, direct substitution, that's numerator going to 0, denominator going to 0, we call this is indeterminate form 0 of 0. Second part is indeterminate form is x approach to infinity. X plus 1 go to infinity. X minus 1 go to infinity, which meaning is they keep increasing, that we call this limit. Infinity of infinity. So these two forms, indeterminate forms. So when you have this form, we're gonna use L'Hopital rules. What is L'Hopital rules? Guys, here is, look at this first part of limit. Limit always a fraction form. That's you have to remember that. Fraction form. Fx over gx. We talk about indeterminate form 0 over 0 or infinity over infinity. That case, we're gonna find this left side limit to this way. Take derivative f of x, that's f prime x. Take derivative g of x, that's g prime x. Then we're gonna find the limit of this. Then you have this one, another 0 over 0 or infinity of infinity, then you're going to do one more time. So here's very important. The concept is right there, guys. Make sure it here. L'Hopital rule is, guys, here is L'Hopital rule. Only indeterminate form 0 over 0, infinity of infinity. So when you want to use L'Hopital rules, make sure only 0 over 0, infinity, infinity form, indeterminate forms. Other indeterminate form we're going to study later. Let's just start the example with 0 over 0 indeterminate form. So first, you have to check it out. This is going to be 0 over 0 form. So x approach to 2, guys. This one going to 0. 2 square minus 4 equals 0. This one going to 0. That case, we can use L'Hopital rule. So limit x approach to 2. Derivative x square minus 4 is 2x. Derivative x minus 2 is 1. Then you're going to do direct substitution. X approach to 2. This is a 4 over 1. That's going to be 4. So this limit, we can find the 4 by using L'Hopital rules. So you have check indeterminate form. Let's go to second one. Second one, let's approach x approach to 0. Top is going to where? 1 minus cosine 0. Cosine 0 is 1. 1 minus 1, 0. Sine gonna be sine 0 is 0. This one is a 0 with 0 form. So we're gonna use L'Hopital rule about this limit x approach to 0. Derivative 1 minus cosine x, 1 minus derivative cosine is negative sine x. Derivative sine is cosine x. So limit x approach to 0, sine x over cosine x. Direct substitution gonna be sine 0 of cosine 0. Sine 0 is 0, cosine 0, 1. The limit gonna be 0. Guys, remember, I emphasize here a couple of times, this gonna be always 0 over 0 form. You're gonna use L'Hopital rules. Let's do more examples. Just to pause the video, you're gonna practice this limit. So before we use L'Hopital rule, check it out. X approach to 1. What happened this one, guys? What happened? This one is gonna be ln 1 is a 0. 1 minus 1 is a 0. This one is going to 0. This one going. So what is gonna be? C gonna be limit x approach to 1. What is derivative of ln x? That's the 1 over x. Derivative x minus 1 is 1. That's limit x approach to 1. That's going to be 1 over x. That's going to be 1. That's how you find this limit. Let's go to D. So let's check it out. This one going to where? X approach to 0. This one e to the 0 minus 1. 1 minus 1, that's going to 0. This one going to 0. So also this one is a 0 with 0 form. So we're going to using L'Hopital rule right here. Limit x approach to 0. This one is ex. Derivative ex is e to the x. Derivative x is 1. So you plug in e to the 0. That's the 1. That you're going to find this limit. Next slide, we're going to study indeterminate form infinity of infinity. This slide, we're going to study indeterminate form 0, infinity of infinity. L'Hopital rule say we still can use L'Hopital rule for the infinity of infinity. So here is going to be infinity of infinity, guys. So we're going to use L'Hopital rule. Before we use L'Hopital rule, let's check it out. This is going to infinity of infinity, the e to the x. So e to the x approach to infinity, that's going to infinity. So if you don't remember the exponential function, looks like it's exponential right here. That's gonna be y equal e to the x. That's x going to this infinity, y going to infinity. That's why this going to infinity. X squared, of course, this going to infinity. So this one is infinity of infinity form. You can use L'Hopital rule. So limit x approach to infinity, e to the x derivative e to the x squared derivative 2x. So check it out one more time. E to the x going to infinity, 2 to the x going to infinity. Oh, we cannot use L'Hopital rule one more time. Derivative e to the x, derivative ex is 2. Now, x approach to infinity, this going to infinity, bottom going to 2. So whole thing going to infinity, getting unbounded, getting bigger. Let's go to B part, guys. Before you attempt to use L'Hopital rule, check it out. ln x function. Everyone remember ln x graph? Graph of ln x looks like this. That's gonna be ln x. Y equal ln x. X approach to infinity, meaning is x going to this direction. Y value is infinity too. So this going to infinity, this going to infinity. So you constantly use L'Hopital rule. So derivative ln x, 1 over x. Derivative x is 1. Limit x approach to infinity, that's 1 over x. what is the limit of 1 over x as x approaches infinity? X approaches infinity meaning is number is getting bigger, x is getting bigger and bigger. Then which meaning is 1 over x. Denominator is bigger, 1 over x going to 0, guys. So this limit goes to 0. So next slide, we're going to practice more. But before I show the solution, guys, practice them on your own. Let's do another example, guys, here. So we have checked it out. I just emphasize one more time, guys. Look at this one. Infinity of infinity, 0 of 0. You're going to use the L'Hopital rule. So let me check it. X squared minus 2, that's polynomial function. This part going to 0. Oh, no, I'm sorry, going to infinity. This one also going to infinity. Guys, infinity means in math, number is getting bigger. So we're going to use L'Hopital rule here. 3x squared minus 2, and derivative of 3x squared minus 2 is 6x. X squared plus x plus 1, 2x plus 1. So let me check it. This going to another infinity. This going to infinity. Number is getting bigger as x is increasing. So this one is L'Hopital rule one more time. Derivative of 6x is 6. Derivative 2x plus 1 is 2. This limit 6 divided by 2 is 3. So limit of c gonna be 3. Let's do d part. Could you check this form? So x approaches to infinity. This is getting bigger, increasing. This one also increasing. So this is infinity of infinity. So we're going to use L'Hopital rule again. 3x minus 2 derivative is 3x. Now you have very careful. 3 is constant, doesn't change anything. 2x. Bottom going to infinity. This one going to infinity, guys. Bottom number is getting bigger. Whole thing getting smaller. So this limit is gonna be 0. So now we study indeterminate form 0 over 0, infinity over infinity. Now we're gonna study different indeterminate form. Next slide. Now we're gonna study different indeterminate form. The first different indeterminate form is, guys, look at this, 0 times infinity. So look at this one is e to the negative x, guys, that case. So e to the negative x graph gonna be, guys, e to the negative x graph looks like this. That's the y equal e to the negative x. So x approach to infinity, e to the x gonna be, e to the negative x gonna be going to 0. So x going to infinity. That's why this is 0 times infinity form. So that case, we cannot use L'Hopital rule right away. So make sure L'Hopital rule always apply 0 over 0, infinity over infinity. So you need another step to take before using L'Hopital rules. Another indeterminate form is infinity minus infinity, 1 over x minus 1 over x squared. So I'm going to sketch the 1 over x graph. If you remember, this is 1 over x graph. X approaches the 0 from the right, this one going to infinity. So 1 over x going to infinity. How about 1 over x squared? Same thing, guys. This one is much steeper. Y equal 1 over x squared. X approaches the 0 from the right. This going to infinity. So this one is, this limit we call infinity minus infinity. So you need another technique to find this limit by using L'Hopital rules. So guys, really pay attention next two examples. Now let's have example for 0 times infinity. So what you have to do, this example, guys, we cannot use L'Hopital rule right away. So first step is gonna be, guys, look at this one is first part. What do you have to do, guys? First step is this limit. Only we talk about L'Hopital rule is, guys, previous slides, we talking about only you can use L'Hopital rule is 0 of 0 or infinity of infinity. So you cannot change this one to the 0 of 0, infinity of infinity. So which one you're gonna put in the denominator, you have to make a decision. So I'm gonna decide this one going to denominate. So how can change this form into the fraction limit x approach to infinity. So this one is a square root of x, e to the negative x, e to the x. So e to the negative x, exactly same 1 over e to the x. Now you're going to check this is 0 over 0, infinity over infinity. So x approach to infinity, this going to infinity, e to the x going to infinity, right? I showed the graph of e to the x graph, right? So now you can use L'Hopital rule here, guys. You can use L'Hopital rule here, limit x approach to infinity, derivative square root of x. Guys, remember the calculus 1 class, derivative square root of x gonna be, here is 1.5 x, negative 1.5. Another way, this one is 1.5, 1 over square root of x. So that's gonna be 1 over 2 square root of x, e to the x, derivative e to the x, e to the x. So this one is rewrite the limit x approach to infinity. This one is 1 e to the x, e square root of x. So x approach to infinity, this case, guys, look at this one, x approach infinity denominate. This one going to infinity, which meaning is denominator is getting bigger, whole thing going to 0. That's you're gonna find this limit. Okay, guys, 0 over infinity, you have changed it. So let's try the b together, guys. Look at the b part. X approach to 0. This one is, guys, ln x going to infinity. We talked about this one previous slides. X going to 0. So this is 0 times infinity. One of it should go to denominate. So when you send one of them, you have to decide which one. So I'm gonna decide x going to denominate. So limit x approach 0 positive. Here is top is ln x. X is going to denominate, that's going to be 1 over x. So what do you mean by that? X is the same thing, 1 over x, guys. So you have sent one thing is denominate, make a fraction form. After that, make sure this going to infinity, this going to infinity. So now x approach 0 positive. Find derivative ln x, 1 over x. Everyone, what is derivative 1 over x? What is 1 over x derivative? Gonna be negative 1 over x squared. So negative 1 over x squared. What is this simplification limit? X approach 0 positive. 1 over x times negative x squared over 1. Fractional fraction, you flipped denominate. So this one is limit x approach to 0 positive. Here is a cancel out x squared. Here is x. That's gonna be negative x. So this is gonna be 0. That's how to calculate. That's how to find 0 over infinity. What I really want you to remember here, guys, this form is 0 over 0, 0 times infinity. You have changed 0 over 0 or infinity of infinity, then you're going to use L'Hopital rules. This is the last part of indeterminate forms, infinity minus infinity. This is very tricky limitation, guys. So we always try to change this one, guys. 0 over 0. 0 of 0 or infinity of infinite form to use L'Hopital rule. That's the main idea, guys, okay? So let's try A first. This one is not easy part, so take a time to do it. Limit x approach the 1 plus. So this one is put together. So this one is ln x times x minus 1. Here is x minus 1 minus ln x. So if you check it out, this one is gonna be 0 of 0, guys, okay? So now what you have to do, using L'Hopital rule, because this is a 0 of 0 form. So L'Hopital rule, very carefully, you're gonna do it here, x approach the 1 positive, which means coming from right. Let's to take a derivative. X minus x derivative is 1. Negative 1 derivative is 0. ln x derivative is 1 over x. You're going to use the product rule. Everyone remember the product rule. ln x, derivative ln is 1 over x. X minus 1 plus ln x, derivative x minus 1 is 1. So here is, now we have to simplify. I want to times here, whole thing gonna be x, whole thing gonna be x, to eliminate x denominator. So when you do that, limit x approach the 1 plus. X times 1 is x. 1 of x times x is minus 1. Distribute the x, x minus 1 plus x ln x. X approach the 1 from the right. This one also gonna be 0 of 0 fun again. So we're gonna use it one more time, guys. Look at this L'Hopital rule. Limit x approach to 1 positive. Derivative x minus 1 is 1. X minus 1 is 1 plus another product rule. Derivative x ln x plus x times derivative ln x 1 of x. So this one is cancelled out. What do you have here? Limit x approach to 1 plus 1 over 1 plus ln x plus 1. See that? Now, x approach the 1. What happened here? 1 over 1 plus ln 1 plus 1. But as you know, this is a 0. So our final answer is going to be 1, 1 plus 1. That's the 1 over 2. That's you're going to find this limit. Guys, make sense? Let's practice one more indefinite form infinity minus infinity. So before we start, let's check it out, this limit. X approaches 0 from the right, sin x going to 0, which meaning is a whole thing going to infinity. X approaches 0 positive, 1 over x going to infinity. That's going to be infinity minus infinity indeterminate form. So how gonna find this limit gonna be, guys? So limit x approaches 0 positive from the right. Put together, here is sin x times x, x minus sin x. This, of course, 0 over 0 form. Now you're going to use L'Hopital rule. So x approach 0, this part going to 0, this part going to 0, this one. So this one going to 0, sin x going to 0, x going to 0, this is going to 0. So 0 over 0 form, we're going to using L'Hopital rule. So find the derivative of each. 1 minus cosine x, product rule, derivative sin x cosine x times x plus sin x times derivative x is 1. So let me check out one more time. This one is, we can apply L'Hopital rule one more time. X approach to 0. This one is 1 minus cosine 0 is 0 because cosine 0 is 1. Cosine 0 times 0, sine 0 times 1. This one going to 0, this one going to 0, so this one is 0 over 0 form. So now we're going to using L'Hopital rule one more time. X approach the 0 positive. Derivative 1 minus cosine x, derivative cosine x is negative. Here is a positive sine x. Use the chain rule one more time, guys. The chain rule, here is cosine derivative negative sine x times x plus cosine x times derivative x is 1. Derivative sine x gonna be, here is plus cosine x. Okay, let's go this limit. So this one is sine 0 times 0 cosine 0 times 1 plus cosine 0. So sine 0 is what, guys? That's gonna be 0. Sine 0 is 0, this one is 0. Cosine 0 is 1. 1 times 1 is 1. Cosine 0, 1. So this is 0 over 2. That's gonna be 0. That's how to find infinity minus infinity in the determinate form by using L'Hopital rule.